Fibi is an autonomous home robot. Fibi represents a new design philosophy in robotics, which incorporates recent advances in AI from the ground up.
Fibi is a blimp robot supported by a 36-inch circular helium balloon. We wanted to design our robot so that it naturally balances itself to float around the home freely. To achieve neutral buoyancy, one of our main constraints with this blimp platform was the robot's small payload. The body of Fibi was designed to be very lightweight, simple, and elegant. It was designed with functionality in mind, aerodynamics, mounting, and encasement of hardware. We also really wanted it to carry a gentle and comfy feel around the home. It has soft edges and minimalistic design. It was vacuum formed against a resin mold. We played around with different splines, materials, thicknesses, and colors to optimize the design. We were able to get this beautiful body just below 10 grams. However, we still needed rich sensing data from a small mass. This led us to relying on a camera as our main sensor, along with an IMU and an ultrasonic sensor to perform our navigation.
Recent advancements in CPU and GPU performances that we have seen in the past few decades have allowed us to access what we now call deep learning. As opposed to traditional computer vision algorithms, the beauty of deep learning is in how each layer learns more and more complex features as we increase the number of layers in the model. As you may know, helium can't lift too much weight, which became something early on that established Fibi's hardware limitations. A single monocular camera became its main source of sensory input, from which it was clear that using deep learning was going to be the perfect pairing for Fibi.
Fibi uses a convolutional neural network in order to determine if the path is safe. We trained Fibi using thousands of images from around a home, telling it which were collision-free. The data was collected by scanning rooms and furniture with Fibi's camera, while using a distance sensor to automatically label whether anything is too close. This means that the network is being trained to output a probability of collision if a particular trajectory is followed. By using multiple crops of the same image, we can simulate Fibi being in different places and following different trajectories. By using all of this information, Fibi's controller can generate commands to stay collision-free. To make Fibi even better, we explored several improvements to our network. We wanted a more robust and scalable system without having to compromise on runtime. This resulted in the creation of a new architecture that is able to make predictions for all trajectories of interest in a single forward pass. Instead of collecting new data with more sensors and labels, we augmented what we had already collected by perturbing what the network was saying. This network outputs the same information as before, but is faster and scalable to many trajectories.
Another method for collision avoidance is via deep reinforcement learning. Deep reinforcement learning provides a framework which consists of an agent interacting with its environment. The agent receives reward depending on whether or not it's doing a good job. We use this general framework to train a deep convolutional neural network to perform collision avoidance in simulation, which we transfer to real robot.
Fibi presented many control challenges, but by combining angular velocity measurements with a ground-facing ultrasonic sensor, we were able to get the minimal set of measurements needed to control Fibi. We've combined various control schemes and optimized our controllers for maximum performance.
Currently, Fibi is using the Raspberry Pi Zero W, a small and light computing unit with low power consumption. With Wi-Fi and Bluetooth connectivity, is suitable for future IoT application that can make use of onboard and surrounding data. Fibi publishes IMU and sonar data, which clients can subscribe to through the ROS network. Camera feed, however, is streamed through the local network through TCP in order to minimize latency. The neural network for collision avoidance is currently running off-platform on a separate host machine, which has more access to more powerful graphics and hardware. We are also incorporating Alexa into Fibi for a more comfortable and natural hands-free experience. Alexa, start Fibi.
Hello, my name is Phoebe. How can I help you?
Hi Phoebe.
Hi Calvin. Do you need something from me?